we introduced list to you in the previous session, but let's revise that particular thing. So it is a compound data type. It is used to store number of values together, and it is written as a list of comma separated values between square brackets. We saw this particular square bracket notation separated by commas yesterday also. It might contain items of different types, so you can have integers and floats and characters and strings all inside a single list. That won't produce an error. Lists can be indexed and sliced, the same that we saw in strings. Even in list also we can perform indexing and slicing. So so this particular list we have squares equals to 1, 4, 9, 16, 25. So when I say squares of 0, this will print 1. Squares of minus 1. We can also have negative indexes over here. So when I say minus 1, it will start from the end. So minus 1 will denote the last character. So when I say squares of minus 1, that will print 25. When I say squares of minus 3, up till that will go up to the end of the string, not the start of the string. Even though we have negative indexes, it will still go to the end of the string. So when I say negative 3, so negative 1, negative 2, negative 3, so it will start from there and go to the end of the string. Similarly, we have the slicing operations. So yeah, so if I don't mention any of these parameters, it will basically print the entire string, entire list. Sorry. Also, just like strings, lists also support concatenation operation using this plus operator. So we can actually add up two strings and it will produce one gigantic string. As you can see, the squares in our previous PPT, previous slide was 1, 4, 9, 16, and 25. But over here, I have also added these all values. Sorry, these all values. So this is what we get as the output. So the previous string, also the character, also the list items which we have added. Now, unlike strings, which are immutable, lists are a mutable data type. That is, it is possible to change their content. So, if I say this is cubes, okay, so 1, 8, 27, 65, 125. Something is wrong over here. Why? 1 cube is 1, 2 cube is 8, 3 cube is 27, but 4 cube is not 65, it is 64. So, yeah, we can replace this particular 65 with the actual value, that is 4 cube is going to be 64. So what we do is simply mention the index at which we want to make the changes and then mention the value. So we replace that particular value with another value and we get this output as 1, 8, 27, 64, and 125. So that won't lead to any error. In case of strings, we had to encounter such errors, and also in case of tuples, which we'll be looking forward to, even in those cases, we will be encountering errors, but not in case of lists, since lists are a mutable data type. These are some of the list methods. Append method, which is used to add an element towards the end of the list. This clear method, it is used to uh, clear the entire list. Then we have the copy method, count method, extend, index. We'll have a look at some of them in right now. So just give me a minute. Yeah, so this thing. First of all, we have this L1 variable which holds values 123, Synergy 2.0, KJC 55. So as you can see, we can literally have any data type in the list, and we can have variety of data types in the list, not just one. It's not fixed, unlike arrays which we have seen in C, C++. This is a little different. We can actually have different data types in the string. So yeah, so when I print those, that won't give any error. Also, lists do support indexing and slicing, which we have mentioned. So li of 0 will give the element at the first position. So li of 0, that will print 1, 2, 3. Li of 1, 2, 3. So that will print the element at index 1. So this is index 0, this is index 1. So this will print synergy and 2.0. It won't print KJCY because it will start at one index before 3. So that is going to be 2. So it will print the element at index 1 and it will print the element at index 2. So yeah, this does the job. And then we have this L2. So we can print right from this second index. So this is again the same slicing and indexing operation. and we definitely have a look at that. Also, we can, as we have seen in strings, we can print the strings two times using multiplication. So when I say L2 into 2, it will print the L2 list two times. So yeah, and then we have L1 plus L2. So we can actually concatenate two strings. So that can be two variables or two constants, variables and a constant, just like strings we had seen before. So over here I'm adding Li and L2. So Li is 123 Synergy 2.2 KJC and 55. L2 is Python and 140. So when I concatenate both of them, I get this output where we can find all these elements. Now, these are some of the list methods which we have mentioned in the PPT. Now, let's have a quick look at all of those. First of all, we can obviously find the length. We can find the length of actually every sequence data type which we have, be it list, be it sequence, be it tuples and sets and everything. We can find the length of everything. So using this particular length method, length function. So this gives the output as phi, that is the length of this list. Then we also have a max method, which is used to find the element with the maximum value in that list. So over here it is 45, so it prints out 45. It's quite obvious with the name max. Also, when it comes to strings, and then I want to find the max element, it will actually go with the actually it goes with the Unicode order, but you can consider this particular thing as the alphabetical order. So since P is the one which occurs after C and J, so this the Python will have the greatest value. So it will print Python. And again, it as its counterpart of as the counterpart of max function, we also have the min function, which does exactly the opposite task. Next, this is the append method where we can append some values to the list as well. So if I have this particular list, Python, Java, and C++, and I want to append another value to it, for example, PHP. So what I basically do is L2 dot append. Append indicates it wants to append or insert a value towards the end of the list. So what it will print is Python, Java, C++, and PHP. And yes, this is exactly what we get as the output. Next is we can also insert. This was append method, which was a method that would insert an element towards the end of the list. But suppose we want to insert an elements in between at the index of our choice. So in that case, we make use of insert method. So over here, I've initialized this L2 string L2 list, which is consists of Python, Java, and C++. So if I insert Perl at index one, so this is index zero, Python. So what I want to do is I want to insert Perl after Python, that is it at index one. So what I do is L2 dot insert. First parameter is the index where I want to insert, and the next parameter is the string which we want to insert or the item which we want to insert inside the list. So when I say print L2, that would actually, we can see the output as Perl inserted at index number one. Similarly, if we want to remove any element, all we do is mention the element, the value of that element which we want to remove, and that gets removed. And since we print the output, and we get the result as Java, which is removed from the list. Again, one thing to note, these methods, insert, remove, or append, these are destructive methods that because they alter the original list, the original sequence which we have. So when I say L2 dot remove Java, it will actually remove Java from that list only. So when I again print L2, I won't find Java over here because that is removed from the original list only. Next, what we have over here is pop. What pop basically does is it pops out the last element, that it removes the last element from the list. So when I say L2 dot pop, that would remove C++ from the list. And when I say print L2, we cannot find C++ over here. Another method which we have is reverse, that will, as the name suggests, reverse the entire list. So yeah, so Python, Perl, Java, and C++ will get reversed into C++, Java, Perl, and Python with the help of reverse function. Now, another method which we have is sort. So I'll just demonstrate using an example. So suppose I have a list which consists of these values. Now I want to sort this particular list. So what I basically do is x dot sort. Now let me run this first of all. So what it will do is it will not give us any kind of output. Why? Because it will not actually return something. It will just modify the original string, original list. So it will not return anything and therefore it will not print anything. So I need to explicitly print this, and as you can see, the output is a sorted list with elements ordered as 1, 2, 4, 5, 6, 7. So again, sort, it is a destructive method. It alters the original list. So yeah. And then when I say reverse equal to true, what it will do is it will sort the string in ascending order, sort the list in ascending order, and then it will reverse it. So at the end, what we get is the descending order. Over here, you can see we have C++, Java, Python, and Ruby. When I sort them, it should be like C++, Java, Python, and Ruby. But since we have also used reverse, so it will lead to Ruby, Python, Java, and C++. So yeah, this works like that. We have seen how sort works. Even in case of strings, as I mentioned before, it basically sorts your list in alphabetical order. So this will print it as C++, Java, Python, and then Ruby. Uh, Okay, so now you can see over here we have a tuple. Yesterday we talked about tuples. So tuples can be initialized using parentheses, the circular brackets notation. So this T2, it is a tuple. Now I want to convert this tuple into list. So what I do is simply list parentheses and the tuple which I want to convert. So when I do this, it will convert T2 into a tuple and then return a value. Notice it will not alter T2. T2 will still remain a tuple. What it will do is return a list which consists of all these elements. So what I get is L equals to this complete list. So yeah. Now next let's move on to tuples.